we're going to use the fundamental counting principle, and you're going to see how easy it makes some of these problems. So an ice cream shop offers 1, 2, or 3 scoops of ice cream from among 12 different flavors. The ice cream can be served in a wafer cone, a sugar cone, or a cup. We're going to use the fundamental counting principle to determine the number of choices possible. So I need to see how many different options I have. Well, I have my number of scoops, that's one option. Number of flavors, that's another option. Okay, and my serving option, that's my third option. And that's going to tell me how many choices I have of ordering ice cream. So remember, the fundamental counting principle said we're just going to multiply these different options together to get the number of choices or the number of outcomes. So first of all, number of scoops. How many different choices do I have for the number of scoops? Well, I can get 1, 2, or 3, which means I have 3 different choices for a number of scoops. Number of flavors. How many choices do I have for the number of flavors? I have 12 different choices. And serving options. How many choices do I have for serving options? Well, I have wafer cone, sugar cone, or a cup. That's 3 different options. And the fundamental counting principle tells me I just multiply these 3 numbers together and it'll give me the number of outcomes. 3 times 12 times 3 gives you 108, and that's how many choices you have for ordering ice cream. Now, remember, if you would have made a tree diagram, you would have gotten this 108. But can you imagine making a tree diagram where you go out 12 options each time and then go out 3 options from each of those? It would take forever. It's much easier and faster to just use this fundamental counting principle. Looking at part B, Jimmy needs to make a 3-digit password for his logon name, so it's a 3-digit password on a website. The password can include any digit from 0 to 9, but the digits may not repeat. We want to know how many possible 3-digit passwords are out there. Well, we need to think about the 3 different choices we're going to make and how many options we have. So if I think about it, I've got my first digit, my second digit, and my third digit. I can choose any digit from 0 to 9. And so from 0 to 9, there are actually 10 different digits. But the digits may not repeat, which means I have 10 to choose from for my first option. But then I choose one. So let's say I've got my 10 digits. I'll just write them down off to the side. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are my 10 different options. Let's say I chose 3 for my first number. Can't repeat, so I can't use 3 again. That means how many options do I have for the second digit? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 options for the second one because I've used one up. So let's say I use 6 as my second number. Well, now there's only 8 numbers left because they can't repeat. So I've got 8 options for my third one. And now I can just use the fundamental counting principle. And you may be saying, well, what if I chose 2 and 8 for my first 2? It would be the same thing. As soon as you use one up, you can't use it anymore. So that's why we have 10 options for the first, 9 for the second, 8 for the third. Fundamental counting principle says all I have to do is just multiply these together. That'll tell me how many options there are. 10 times 9 times 8 gives you 720 possible passwords. Again, using this fundamental counting principle makes things way easier than using that tree diagram like we saw in example 3.